to the demonstration of the experiment on comparison of two cells by potentiometer. Now the aim of this experiment is that I want to compare two cells, and those two cells are Daniell cells and standard cell. And for this experiment, we'll be making use of some apparatus, which includes accumulator, which we are expected to use either an accumulator or a regulated power supply. So for this setup, we'll be making use of a regulated power supply, which is going to serve as our accumulator. And also we'll be making use of a potentiometer, we'll be making use of a rheostat, a standard cell, a Daniell cell, a galvanometer, and also a protective resistant box. So those are the things that we're going to be working with. And we also need our connecting wires to connect those things. Now if you look at this circuit diagram, you see that the D here represents our Daniell cell, while this symbol here, where you have your P, is our protective resistance. And the G here is our galvanometer. We also have a jockey that we're going to be using we are going to be putting on the potentiometer in order for us to determine the balance points on the galvanometer. Also we have our C, which is indicating our accumulator. Remember I said that our accumulator in this case will be making use of our regulated power supply. We also have our rheostat, and that's why you have that arrow to show that it's a variable resistor which you can vary from one point to another. Now, the galvanometer we are going to be using is the center tap galvanometer, where you have your zero position at the middle. Is either going to deflect to the right or to the left. And for our table of values, we are expected to have, remember that the title of the experiment is what? Comparison of two cells. And like I said, we are comparing our Daniell cell, and also we are going to compare it with our standard cell. So from this experiment, we are going to be getting from the calculation, we are going to be getting the EMF of the Daniell cell, and now compare it with whatever value that we already have for our standard cell. So can we now move to where we have our setup? That we have on the board there is already what we have here. This is our regulated power supply. You can see it has a switch button, it has the on and the off. And before you do anything, you are supposed to determine first the value of the Daniell cell that you are using. To be sure that the Daniell cell that you are using, the battery is okay. It's giving you the actual value, which is supposed to give us 1.5 volts, because the battery we are using is just a single cell, just a single Daniell cell. So it's expected to give us just 1.5 volts as the value. And we can use that, we can determine that by connecting wires to the two terminals. It has a positive terminal and a negative terminal, which you can connect to the terminals of our voltmeter. We have a voltmeter here. You just pick your voltmeter, you connect the two terminals to it, and it will display the value of your battery. So that by the time you connect your experiments, you'll not be having issues. Probably you are using a battery that has a very low voltage and you're not getting anything. So when you have done that, you now take your connecting wires, you connect from this diagram that we have here. This side that is longer is the positive terminal, while the shorter one is the negative terminal. The same thing where you have your accumulator, which we are replacing with our regulated power supply. The longer line is the positive, while the shorter one there is the negative. So which means that we are connecting the positive terminal of our Daniell cell to the point A on the potentiometer. That line that we have at the middle that says A to B is indicating our potentiometer. So this is the point A of the potentiometer, and this is the point B of the potentiometer. So you connect the positive terminal of your Daniell cell, which is this positive terminal here. Now if you look at it, it's always indicated on the side. They write it positive or negative, but you can also determine by looking at it physically. When you touch the positive part, the negative part is the part that is flat, while the positive part is the part that has a little bit of a bulging metal at the edge. So you connect the positive terminal of your Daniell cell to the point A of the potentiometer, which is what we have here. And also from the potentiometer, you now connect again to the positive terminal of your accumulator, and that's what we have done here. You can see the wire is coming from this point to this point. That's your positive. Then the next thing you do is that you connect the negative terminal also to your rheostat. This is your rheostat. Your rheostat has 3 terminals. It has one terminal to this side, to one side of it, and it has two terminals to the other side. Now, the point you are going to be connecting your wires to determine the kind of experiment that you want to carry out. There are some cases where you are carrying out an experiment, you have to make use of the 3 terminals. But for this experiment, we are making use of just 2 terminals, which is the one at the lower point at this point and the upper one that we have here. If you connect at the lower point and you connect here, you're not going to get anything. You just keep connecting and trying all day and you won't get anything. So we connect to this side and you also connect to this other terminal here. So from this terminal, from your diagram, you see you go towards B, and this is our B position. So you connect from here straight down to this point to give you what? The connection that we have there. The next thing is that the negative terminal that is coming from your Daniel cell, it goes to your protective resistance. This is a protective resistance. What it's doing in this experiment is that before we start, this has to be connected. We want to protect what? The galvanometer, in order for it not to be damaged. So you connect this negative terminal, you connect it to this point. You take the other terminal here and connect it towards the negative point of the galvanometer. While you take your jockey, you connect it on the positive either point. If you connect it, it's still going to give you a reading. If you connect it, it's still going to give you a reading. So this is what I was saying, that is a center tap. It can connect both to the right side, which is the positive reading, and it can connect also to this other side, which is the negative reading. You have other galvanometer that is not center tap, which means that once it connects to the left side, it is what? You have not connected it properly. It can damage what? The galvanometer. So you have this. So now that we are sure that what we have connected is correct, we now put on our power supply. So you can see that the power supply is on, but we have to reduce the voltage. So we have 3. So you can see that from here, this is your voltage, your voltmeter, we're giving you 3 volts. And your current that you're having here is just about 0.41. You take your jockey, we want to now check to see the deflection, if there's any deflection on our galvanometer, either to the right or to the left. So when you put it at this point, that's the one end of your potentiometer. We have labeled this point to be our point A, and this is our point B. Let's say we put it at point B. You see that it deflected towards to the left, which is where you have your minus sign. By the time you take it again to the other end of your potentiometer, it deflects here to the right. You see that, which means that your circuit diagram is okay. So you can now start and continue with the procedures that you are asked to continue with. And what do we now do? Let's look for the balance point. When you want to look for the balance point, you just keep touching at different points, but you don't drag it along the wire that you have on the potentiometer. When you put it on a particular point and it doesn't give you what, when you lift it up again, you pick up another point again like that. So let's see that. So I'm starting from this point. Remember I said it has deflected to this side, so I've lifted it to this side. You have a balance point at 58. You see that? So you have a balance point there. So now that you have a balance point, what's the next thing? You remove your protective resistance. So you remove it by disconnecting the terminals here, and you join it together. So now we don't need it because we know that nothing can happen to the circuit. It cannot damage the galvanometer. So we now repeat what I've just done. All you need to just check again and see where you're going to have. But before you check, you first of all ensure again that it's deflecting. To be sure that probably the terminals of your battery, there have been no maybe disconnection from the terminals. So take it on this point. See your deflection. Remember that the protective resistance is no longer there. Put it to this point also. So we now repeat what we did when the protective resistance was last to get the balance point. So we have our balance point at this point. So you have that. So whatever you have as your balance point, you go to your table and you record. Remember that if you look at the setup that we have here, you see that we have slide the rheostat to a particular position. So you are going to be doing it, you slide, probably the first reading you'll be taking is going to be at this point. You get the balance point, you move it also to another point, you get the balance point, you move again, you get the balance point, you move again, if you get to a particular point, you no longer be able to get any balance point. So you just record your reading, and that's why you have maybe 1, 2, 3. If you have more than 3 readings, just put it on the table. So you have that for the length, where you have your length L, which is length L required for balance with your Daniel cell. So you record the readings that you have there. Let's say you have A, A1, A2, A3. So you can say, we can say A1, A2, sorry, 2, and you have A3. So you have that. You understand? Then the next thing we are now going to do is that we are going to replace our Daniel cell with our standard cell. Remember, we said we are doing what? Comparison. We are comparing 2 cells, which is what? Our Daniel cell and our standard cell, using what? Our potentiometer. Okay, so we replaced our Daniel cell with our standard cell. So we have our standard cell. Our standard cell has also a positive terminal and a negative terminal. So in the same way we connected the Daniel cell, you connect the positive terminal of your Daniel cell to the point A on your potentiometer, and the negative terminal goes straight to your protective resistance and to your galvanometer. But because we have removed our protective resistance, also it just moved from the negative terminal to your galvanometer. So you repeat the procedure again. What do you want to do? You want to get the balance point. So we take our jockey again and we start looking for the balance point as we look at our galvanometer. Watch. So that's our balance point. So you take note of whatever value you have on your potentiometer, or readings that you have on your potentiometer. You note it down on your table. So don't forget that you're supposed to slide your rheostat at different positions, and you take the balance point at those positions, and you take notes of the readings that you have there. So when you have gotten the readings, we now look at the equation that we have on the board, where you have your E1 over E2 is equal to L1 over L2, and from there you can have your E1 is equal to L1 times E2 over L2. Now, remember that your L1, this is your L1, and this is your L2. So for your L1, you have more than one value, which means you have to look for the mean, because you cannot put all the L1 into this equation. So you just look for the mean value of your L1, you look for the mean value of your L2, and you put it into this equation. Then for your E2, you just make use of the value that you have on your accumulator, which is whatever reading that is giving you on your voltmeter there. Whatever value that you have there is what you are going to put as your E2 here, and you determine what? Your E1. You compare whatever readings, whatever value you are having for your E1 with the already standard cell that you are using, which already has what? A value that is written on it also. When you check it, you see that you have about 1.18 volts. That is all about your experiment. But remember that when you are carrying out the experiment, you need to understand that there are some precautions that you need to follow. You understand? When carrying out, especially when it has to do with electricity. Like I said before, I said the first thing you are expected to do is to check. Is the battery I'm using okay? Is the voltage, is it giving me a reasonable voltage, the expected voltage that I'm supposed to get? Then your terminals, ensure that the terminals are tightened. You understand? So that you avoid partial contact. Also, when you are taking your readings on your galvanometer, you avoid parallax error. You don't stand like this and be taking, you'll be seeing something else, because the moment you stand to this side, you are seeing a different value. When you move to this other side, you are seeing a different value. By the time you stand at eye level, you'll be able to get the balance point. So the pointer will be pointing directly on 0. But if you are looking at it on the other side, it should look as if it's pointing at one line to 0. Now don't forget that the same expression you use to determine your E1 for your Daniel cell is the same expression you are going to use to determine your E2 for your standard cell. Then you now compare the values that you have. Thank you.